Hello. Today we are going to be talking about topic 7.7 and going through the examples that were assigned. That's example 1, example 3, and example 4. I'll be doing this video by each example. So this will be the first video, and then you'll have a separate video for example 3 and a third video for example 4. That keeps them in little short snippets. So you don't have to watch a really long video, and it also allows you to easily pick back up and just watch one video at a time. So our first question deals with the vocabulary for this section, and it is, what is a perfect square binomial or trinomial? That's a T. So a trinomial we know has 3 terms, and a perfect square trinomial is simply the result of a binomial squared. Binomial, that bi stands for 2 terms. So let's look at these very special cases that topic 7.7 deals with, specifically perfect square trinomials. So a plus b times a plus b is equal to a plus b squared. That's just another way to write a plus b times a plus b. And so this is a binomial that is being squared. If we want to square that binomial, then we're going to get a very special case, and we can prove this case by drawing out our area model using our box. So we have a plus b times a plus b. So a times a squared, a times b, ab, a times b, ab, and then b times b is b squared. If we bring that out of the box, we have a squared plus ab plus ab plus b squared. When we combine these 2 terms, we have a squared plus ab, that's an understood 1 in front of each one of these. 1 plus 1 is equal to 2 plus 2 ab, and then plus b squared. So when you have a perfect square binomial that is a plus b, you will always have this model, a squared plus 2ab plus b squared. Well, what about if you have a minus b squared? Let's look and see how this will differ when we use our area model again. So we have our area model, and we have a minus b, a minus b. The first term is still a times a, so that's going to be a squared. The second term is now negative b times negative b. Negative b times negative b is b squared. And the reason why it's a positive b is because a negative times a negative equals a positive. Now let's look at the middle 2 terms. We have a times a negative b, so that's a positive times a negative, which gives us a negative, negative a, b. And then we have a times a negative b. Once again, a positive times a negative gives us a negative, so that's negative ab. And when we bring it out of our box, we have a squared minus ab minus ab plus b squared. So combining our middle terms, we get a squared minus 1ab minus 1ab, which is minus 1 minus 1. So minus 1 minus another one, meaning you owe somebody $1 and you borrow $1 more. How many dollars are you in debt? $2 minus 2ab, and then plus b squared. So when you're looking at a minus b squared, it looks very similar to the a plus b squared. The major difference that I want to draw your attention to is going to be this middle term. There's still 2ab, but if it's a positive 2ab, then you know that there's a positive sign, a plus sign in between the a and the b. And if there's a negative, then there's a negative sign in between the a and the b. Now let's put our model to practice. Let's try one. In your example, we have x squared plus 14x plus 49. So step one, when you're dealing with these types of problems, is that you always ask the question, is the first term and the third term perfect squares? What is a perfect square? A perfect square is when you can multiply one number by itself and it will, then it's a squared term. So if they are perfect squares, then that's step one to check to see, do we have a perfect square trinomial? To conduct step two, we have to identify what our a and our b is. So here, if this is a perfect square trinomial, this is going to be a squared plus 2ab plus b squared. Now, what is the square root of x squared? So what can you multiply by itself to get x squared? It's going to be x, because x times x equals x squared. So x squared plus, and I'm just going to hold these open for right now. We know it's got to be 2 times a and b. What is, if b squared is equal to 49, then to solve for b, we would simply take the square root of both sides, and b is equal to 7. So we know that x squared is equal to a squared, which is a perfect square, and 7 squared is equal to 49. So if this is truly a perfect square trinomial, then this middle term has to be equal to x times 7. Well, x times 7 is 7x, times by 2 is equal to 14x. So it is a perfect square trinomial. Check. Since that checked out, we know that now we can factor it without having to go through the entire puzzle. We can factor it simply by saying a plus b. Well, we've already identified our a. Our a is x, because a squared is x squared, which is that first term. So this is equal to x plus our b. Our b is 7. We identified that right here. So x plus 7 squared is how we would factor x squared plus 14x plus 49. So step 2, 2 times A times B must hold true. All right. So now let's look at the next problem. The next problem says that 9, so it's asking us to factor. We're still in example 1. This is just part B. Factor 9x squared minus 30x plus 25. One thing that you might want to notice here is that your coefficient on your x term, on your x squared term, does not have to be 0. Does not have to be 1. So very important, very important, very important. So if we believe that this is going to be x squared minus 2ab plus b squared, we need to find out what our a is and what our b is. So at this point in time, we have a squared is equal to 9x squared. To solve for a, you simply take the square root of both sides. Square root a squared, square root 9x squared. The square root of 9 is 3. The square root of x squared, as we saw in the previous problem, is x. So a is equal to our 3x. We need to solve for b. B is equal to 25, or actually b squared is equal to 25. So b, to solve for b, you're going to take the square root of both sides. The square root of 25 is 5. So now we can check to see if negative 30x is equal to 2. I'm sorry, leave the sign off for now. We'll deal with that in a minute. We need to see if 30x is equal to 2 times 3x times 5. 2 times 3 is 6. 6 times 5 is 30. So 30x equals 30x. We are dealing with a perfect square trinomial. So now we have 3x, simply our a and our b squared. So 3x and 5. We know this is going to be squared, but here comes where the sign comes in. So remember in our previous, when we were first reviewing, this sign comes in when we discover whether it's a plus b squared or a minus b squared. Since this is a negative 30x right here, then we know this has to be a minus b squared. A minus b squared. So even if you do run into some that have the coefficient of the first term is not 1, you can still solve it by just saying if this is equal to a squared and this is equal to b squared, then I need to solve that by taking the square root of a and b, and then I can plug it into my model of a perfect square trinomial is equal to the square of two binomials. So that's a plus b squared, a minus b squared. They're very similar. The only difference is one is a positive 2a in the center, and this one is a negative 2a in the center. That's it for example 1. If you have any questions, please feel free to reach out to me either via email or text or Google Classroom or Remind, and I'll be glad to answer them. Stay tuned for example 3 coming up next.